Okay, today we're going to discuss end behavior of polynomial functions. Before we discuss the end behavior, I'm going to talk about a couple other topics here. You're going to organize your polynomial function so that it is in descending order of exponents. The highest exponent you have is known as the degree of the function. When you have the degree of the function, you have two choices. You can either have an even or an odd degree. Since this is a 3, this is an odd degree function. All right, second thing is you take the number that's with the exponent, this term, and that's going to give us our leading coefficient. So our leading coefficient, again, you're going to have two choices, either going to be positive or negative. So in this case, it's a 2, so it's a positive leading coefficient. Let's try another example. All right, tell me about the degree. So the degree, in this case, is going to be even. My leading coefficient, choices are negative or positive, my leading coefficient for this guy is going to be negative. Y equals 3x. First thing I'm going to do, give you a little table of values. If you can hit pause, fill in that table of values, and then come back. All right, now that you're back, hopefully your table of values coincides with my table of values. And I'm going to just do a quick graph for this guy. This graph is going to look like this. Now, can you describe the degree for me? The degree is going to be odd, because even though it doesn't have it, there's a 1 there. How about the leading coefficient? Choices are positive or negative. This is going to be a positive. So now let's describe the end behavior. So on the right-hand side, we're going to describe this arrow. So what's happening over here is this. As your x's are increasing, so my x's are going to increase as my x's approach infinity. My y's over here are also increasing. My y's are approaching infinity. Now another way to look at that is from the other way around. F of x approaches infinity as x approaches infinity. They're saying the same thing. Now let's take a look at the left-hand side of the graph. So as my x's go down, my y's are also increasing. So as x approaches negative infinity, my y approaches negative infinity. Let's write it the other way. F of x approaches negative infinity as x approaches negative infinity. Okay? So these two here are saying the same thing. These two here are saying the same thing. They are end behavior statements. Okay, let's talk about the second example, y equals 4x squared. Can you create a table of values? Hit pause, fill in a table of values. Great. Hopefully your table of values coincides with our table of values. Now let's talk about the degree. Choices, even or odd. This guy is going to be an even because of the 2. Now the leading coefficient, choices are positive or negative. This one's going to be positive. All right, we're going to graph these very quickly just to give you an idea. Now we know this is a quadratic equation. We know it opens up. Okay, now let's describe this. What's happening here? As your x's are getting bigger, what's happening to your y values? Your y's are getting bigger as well. We're just going to pick one of the ways to write this one. As x approaches infinity, y approaches infinity. Let's take a look at the left-hand side. As x approaches negative infinity, so my x's are going down, what's happened to my y values? The y values are approaching positive infinity. Right side is always this. left side is always this here. Okay? All right, let's take a look at this chart. If you take a look at this chart, okay, this sums up every possible way that the arrows can go. So it goes up and to the right. It's going to have that notation. As x increases, your y is also going to increase. Down and to the left, it's going to have this notation. As x decreases, y's decrease. How about up left? As your x's decreases, your y's are going to be going up. The y's are going to increase. And down right, your x's are getting bigger. X's increase, your y's are going to decrease. Let's take a look at this, see if you can fill out this real fast. Hit pause, fill it out, come back to us. Okay, great. Degree is going to be an odd degree because of the 5. Leading coefficient is going to be negative. So I know, based on that chart on the previous page, that the one side is going to go down here and the other side is going to go up here. If it's an odd degree, arrows are going to go in different directions. Okay, so let's take a look at the right hand side here. I'll use this notation. As x increases and approaches infinity, your y, arrow is going down, it's getting lower, your y is going to approach negative infinity. Now let's talk about the left hand side here. Left hand side is always this. As x approaches negative infinity, so your x are getting smaller on the table, your y's, arrows going up, your y's are going to be getting larger. Okay, now we can do the same thing from the graph. So hit pause, see if you can fill that in for us. Great, now that you're back, both these arrows go in the same direction, so I know that this is going to be an even degree. I don't know what degree it is yet, but I know it's even. My leading coefficient, I know it's going down, so my leading coefficient is going to be negative. Let's take a look at the right hand side. I'm going to use this notation now. What's happening to the y values? The arrow is going down, so your y's are getting smaller as your x's are getting larger. So f of x approaches negative infinity as x approaches positive infinity. Let's take a look at the left hand side. What's happening to your y's there? Arrow is still going down, so your y's are approaching negative infinity as your x approaches negative infinity. Okay, the right hand side is always going to look like this, left hand side is always going to look like this. Alright, let's try the next one. Hit pause, fill it in. Okay, now that you're back, arrows are going in different directions, so that makes this odd. This arrow is going down here, that makes this one a negative leading coefficient. Let's take care of the right hand side here. We'll use this notation on this page. We'll do this one, this whole page with the same notation. Y's are approaching negative infinity as x approaches positive infinity. Left hand side, your y's are going up, arrows going up, your y's are getting larger, f of x approaches positive infinity as x approaches negative infinity. Remember I told you, right side always looks like this, left side always looks like this. If you follow a pattern, right side always looks like this, left side always looks like this. Here's our next one. Hit pause, fill it in, come back to us. Okay, now that you're back, arrows are going in different directions. That makes this an odd leading coefficient. Since it goes down to the right, leading coefficient is going to be a negative. Let's use the other notation on this one here. as x approaches positive infinity, so we're doing the right hand side here, as x's are getting larger, arrows pointing down, your y approaches negative infinity. Take a look at the left hand side here. As x approaches negative infinity, your arrow is going up, so what's happening to your y values? Y values are going up also. Y approaches positive infinity. All right, one more. Hit pause, fill it in, come back to us. All right, now that you're back, both arrows go in the same direction. That makes this an even degree. They're both going up, so my leading coefficient is going to be positive. Take a look at the the right hand side. So as x approaches positive infinity, my arrow is going up. That means my y is approaching positive infinity. Now the left hand end behavior, as x approaches negative infinity, y arrow is still going up. Y's are getting bigger. Y approaches positive infinity. Okay, so that's our discussion on end behavior. Hope you enjoyed the lesson. See you on the next video.